This is going to be covering practice 9.3, which is variable expression rules. On the homework you can have, we're going to go over it in class, we're going to talk about it, but it's going to be practice 9.3 and there'll be 10 questions on it. Most of the stuff is pretty self-explanatory. It gives you a nice little chart, some boxes to fill in and predict what you need to do for the next 7 pattern, essentially. But there's 4 particular problems where they give you a sequence of numbers, and then it says come up with the expression, and then it asks you to come up with like the 20th term or the 100th term. Now what this means is the following. If I'm looking at these numbers behind me right here, this is number 3 on the homework, and this is number 4. Again, just to remember, this is on practice 9.3. Okay? It's an extension of what you did on reteaching 9.3, but it doesn't give you the nice little charts all the time for each question. It expects you to create the charts on your own. So in this particular instance, number 3, it gives you 35, 36, 37. Then it wants you to come up with the expression, and then it also wants you to come up with like the 100th term. So there's actually 2 parts to this question. Now, you can clearly predict what the next number in the sequence is going to be based upon this pattern. 35, 36, 37, so then logically you're going to go like 38 and then to 39, because essentially you're counting up by 1 each time. Here's the problem. If they want to know what the 100th term is, you don't want to sit here and count by 1 to get to 100. And remember, this is the first term. That's the second term, the third term, the fourth term, the fifth term. So if you recall in the last lesson where we had the charts over them, term 1, 2, 3, 4, and 5. The term numbers across the top, and the term itself across the bottom. You know that it's increasing by 1, but that's not actually what the expression is. The number across the top represents a variable like n, and what you need to do is come up with that variable in an expression. So in this case, I have my n variable, and okay, so how do I turn 1 to 35? Well, I guess I add 34 to it. Okay, how do I turn 2 into 36? Oh, I add 34 to it. How do I turn 3 into 37? Oh, I add 34 to it. How do I turn 4 and 5 into 38 and 39? I add 34 to it. So my expression in this case actually ends up being n as my top variable plus 34. Okay, so that gives you actually one of the answers to the homework to help you out. Now, if I'm looking for the 100th term, okay, this means if I extend this all the way out and go all the way down to the number 100, okay, if I go to the number 100, what is the number underneath it going to be? If my expression says n plus 34, that means basically I'm going to take 100 plus 34, because 100 would be on the top spot over here, and then your answer would be on the bottom, and that would have to be increased by 34. So if you did that, and you added 100 plus 34, yes, you would indeed get 134. And theoretically, you should be correct, assuming your expression is accurate, which, as we've tested out, it holds up to each step of the way. Remember, just because it works once or twice doesn't cut it. It has to work every single time. Okay, that's very important. In medical terminology, if you're talking about medicine, it'd be like, or vaccines, if you're talking about efficacy, okay? Is it efficacious? Big word means, does it work all the time, okay? So you need to have that. If something's only 80% efficacious, okay, 8 out of 10 times is pretty good, but it's still 2 other people hanging out, right? So same thing on this. If you're going to make a prediction, you want it to be correct every single time. You don't want to take a chance where you might be wrong at some point. Okay, so if you come down here to number 4, they do the same thing. They give you 8, 10, 12, 14. Clearly they're counted by 2s, right? But then what they don't show you, but you need to show yourself, is 1, 2, 3, and 4. That would be the term number with the term underneath it. So how do you turn 1 into 8? How do you turn 2 into 10? How do you turn 3 into 12? And how do you turn 4 into 14? Newsflash. Hint, it may not always be a single step equation where you're saying n plus 34. It might be something that takes 2 things, all right? It might be something like n plus 2x, or n plus 3x, or n minus 3x. Now when I say that 3x, I'm saying you might be multiplying it by another number. Who knows what that could be, okay? You're not going to come up with a dual variable equation, but what you are going to come up with something is maybe where you multiply by one number and add by another number. So maybe every single time you multiply by 2 and then add 1, okay? So in this case, you'd have something like 2n plus 1, and have to work every single time. I don't know if that's what works there, and I'm not going to figure it out for you, because I already figured out 1 for you as an example. And that means you have 9 more across the page to kind of work out on it. I do recommend, if you've watched the lesson in class when we go over it, which will be tomorrow for some of you, and Friday for the next group after that, this can help you. But if you do want to preview practice 9.3, like we have up there, this is going to be from number 3, and that's going to be from number 4. Just remember, if they give you a sequence of numbers, you want to put the term number across the top of it, and then remember, the top term number is the variable. So when I'm working with n plus 34, my red n matches that red number, and that's because I need to plug that number into this, and if I add it to 34 and I get the black number, then you got it, all right? This is going to be really important as we take it to the next step on the lesson after this, where we're going to have vertical charts with x and y coordinates, 1 on each side, and you're going to be converting one into the other, and you're going to come up with what is called like a y equals equation, like y equals n plus 2 or something like that. So these equations are algebraic-based equations, okay? Most of them are single steps, some of them might be 2 steps. All right, it might be a mixture of adding and multiplying, or multiplying and subtraction, who knows? However, the pattern is going to take out. Key lesson though, just because you can predict what the next number is by counting, that doesn't necessarily help you, because you need to figure out the rule that will work every single time if you want to predict a number way out there. Because I don't know about you, I really, for my homework, would not want to have to sit down, and if it was asking me for the 100th term, I would not want to have to count by 2s 100 times to get that answer. And that's the purpose behind this type of math. It's a shortcut, it's a trick, it's a tool to reduce the workload and shorten the amount of calculation it takes to get the number you're looking for. And that's what a lot of math is about, is trying to figure those things out. Okay, hopefully this short video maybe helps you a little bit. If you pay attention in class, you probably won't even need this video. If you're watching it ahead of time, maybe it'll give you a little edge. Have a great day.